So we have been talking about our stoichiometry problems involving solutions. And in this lesson, what we're going to do is we're going to go ahead and we're going to talk about what happens when you need to dilute a solution, right? Let's say I start with a solution at a certain concentration, but I need it at a lower concentration. Obviously, I'm going to have to add water to it to make it less concentrated or more dilute. But how much water am I going to need to add to make it the concentration that I want it? And that's what we're going to talk about here. We're going to see some problems. How do we go about figuring this out? So we're still working on stoichiometry problems involving solutions. And today we're going to talk about dilutions. All right, so here's the problem. It says a lab has 100 milliliters of a 2 molar NaCl solution. They need to change the concentration to 0.1 molar. How much water should be added? So what we're going to do is we are going to start with the number that's not a molarity, right? And the number in the problem there that's not a molarity is the 100 milliliters. So I'm going to start with 100 milliliters. And this is NaCl, the problem set, NaCl. Okay, now you see they gave me milliliters to start with. Milliliters are not usually what we want to work with. We want to work with liters. So I'm going to use that conversion factor to change my milliliters to liters. So I'm going to put in the bottom 1,000 milliliters so that it matches the top here, and in the top 1 liter. And this is NaCl. Okay. Now what I'm going to want to do is I'm going to want to go to moles. Okay. So the problem said that the concentration of the original solution was 2 molar. So I'm going to use that concentration now to go to moles. So 2 molar means 2 moles and 1 liter. So I'm going to put the 1 liter on the bottom and the 2 moles on the top. Okay. So now I have moles. This is how many moles. And what I'm going to do now is I'm going to use that other concentration, the new concentration, to figure out how many liters that should be. So now what I'm going to do is I'm going to want moles on bottom. The new concentration, it said, was 0.1 molar. So I'm going to put 0.1 moles and 1 liter. And finally, it's probably going to be convenient for me to give an answer in milliliters. So I have liters, I'm going to go back to milliliters now. So 1,000 milliliters and 1 liter, I'm going to put the 1 liter on the bottom and the 1,000 milliliters on the top. So NaCl, NaCl. Okay. And then we're going to go ahead and work out the problem. You might notice there are some things here that will cancel. This 1,000 and this 1,000 will cancel. So let's go ahead and work this out and see what we get. And then we have to be mindful of something. So I have 100 times 2 divided by 0.1. And we get here 2,000 milliliters. Okay, now we have to be careful now. Depending on what the question asked us. The question might have asked us, how much of the diluted solution are we going to make? And then that would be the answer, right? But the question might instead ask us, how much water do we need to add? Okay, let's see, what did this question ask us? This question asked us, how much water should be added? So now to answer this question, we have to keep in mind, originally we already had 100 and we needed to go up to 2,000. So how much water should be added? It's pretty simple. We just subtract, right? So we started with 100 and we wanted to go up to 2,000. So I'm going to add 1,900 milliliters. So be careful with what the question asked you. If they ask you how much water should be added, you're probably going to have to subtract like this to get your answer at the end. If they ask you what's the volume of the final solution, then your calculation will just give you the answer at the end. So be careful with what the question asked you. Okay, let's look at a second example here, and this is going to be a tricky one. Okay, it says if I add 100 milliliters of water to 125 milliliters of a 2 molar NaCl solution, what will the new concentration be? Okay, now the goal in all of these problems is to start with the number they gave you and go to moles and then go to whatever they asked you to find. So getting to moles first is like the first thing. Okay, so let's take a look. What did we start with here? There's 2 milliliters in the problem. Which one should I start with? Well, I'm starting with 125 milliliters and then adding 100 milliliters of water. So let's start with that 125 milliliters and see, how many moles are in that. So we started with 125 milliliters of NaCl. Okay. Now, because we started in milliliters, let's go ahead and use our conversion factor to change it into liters. So 1,000 milliliters is 1 liter. Okay. Now I have liters there. I can use the molarity to find the moles. Okay, and it said the molarity was 2 molar. So 2 moles and 1 liter. So 2 moles and 1 liter. Okay. Now comes the tricky part. Okay. Now it said that we're going to add 100 milliliters. Okay, so we started with 125 and we're going to add 100 milliliters of water. So how many milliliters is the solution going to be at the end? Which is to add those two numbers together, right? So 125 plus another 100 gives you 225 milliliters of the solution. So now here's the tricky part. They asked me to find the concentration. As these cancel, the concentration is going to have moles on top and liters on bottom. Okay, so you see my moles on top? I don't want that to cancel. I want that to stay there because that's what the concentration is. So what I'm going to do now is I'm going to take that 225 milliliters and I'm going to put it on the bottom here. That's NaCl. And on the top, I'm just going to put 1. It's kind of like a number I'm starting with, right? It's a number they gave me in the problem. And if you remember the problems we did the other day having to do with molarity, when we found the concentration, that's what we did. We just kind of put the volume on the bottom with the 1 in the top. Okay. Now, remember the concentration is moles per liter. So I don't want milliliters on the bottom. I want liters on the bottom. So what I'm going to do is I'm going to make one more fraction that's got the conversion factor in there. So it's 1,000 milliliters and 1 liter. I'm going to need those milliliters up here, and look at what's going to happen. They cancel this way. That was NaCl. NaCl. So now if you look at what units I have left over, I have moles on the top, and I have liters on the bottom, and that's what the concentration is. That's what the molarity is. That's what I want at the end. So let's go ahead and work out the answer, and you can see these thousands cancel. So let's go ahead and see. So I do 125 times 2 divided by 225, and I get 1.1 repeating. So I'm just going to round that off to 1.1. And then that's moles over liters, or molar. And there it is. Just as a side note, I do these kinds of calculations all the time. I buy for the school like acids and stuff that are concentrated, and then when we do a lab, I don't give you the concentrated acids. I dilute them. I add water to them to make them less concentrated. So, and we need to know exactly what the concentration is. So I do these kind of calculations all the time in my job. I mean, I happen to be a chemistry teacher, but Okay, so hopefully that helps us to be able to do our stoichiometry problems involving solutions. So until next time, take it easy.